All right, so we're going to go over the homework from integration. All right, so you guys already done some of these. You only had to finish the worksheet. So the first one you guys had to do was number 4. All right, so number 4, we have an example where we have 2 trig functions, and we have different powers. So whenever that happens, we are going to have our u is going to have the trig along with what comes after it in the u. So we're either going to pick tangent 5x or we're going to pick secant 5x. Now you take the one that has the higher exponent. 4 is bigger than 2. So we are going to use tangent 5x as our u. All right. So now you find the derivative of tangent. Now, hopefully you saw that I posted on the Go Classroom. I posted this formula sheet. Okay. Now, if you look, if we're looking for the derivative of derivatives are over here. All right. So the derivative of tangent. Sorry. The derivative of tangent is secant squared. All right. So secant squared u du, which means that just tells you the chain rule. So it's secant squared of whatever comes after it, which is 5x, times the derivative, whatever comes after it, which is 5. Let me throw a dx on there. Okay. All right. So we need to have all of this inside here. So I have secant squared 5x dx. This whole thing right here is almost this. I'm missing a 5. All right. So I'm going to put a 1/5 on the outside like we've been doing. All of this is my du. So this gets all replaced with just a du. And what's left? Tangent to the 5x to the 4th power, which is u to the 4th. Once again, when you have trig in the u, you're probably not going to have trig in the integral. So now I just integrate 1/5 u to the 5th over 5 plus c. So this is tangent 5x to the 5th power all over 5 times 5, which is 25, plus c. All right, and there's number 4. All right, did a bunch of these. Next one we have to do is number 10. All right, so for number 10, this is not a trig problem. So hopefully you're looking like, okay, that's inside. I'm going to make this my u. And you're like, okay, well, I get x squared minus 5. I get du, which is 2x dx. Okay, now remember, all of this has to be an integral. I have dx. This is my u. I can put a 2 in, but I have no x. There's no x on the outside. I cannot add it in there, which means I can't do this by substitution. All right, I can't do this by substitution. So if that's the case, the only other way to do it is to multiply all of this out. All right, now fortunately, it's just squared. All right, so it's x to the 4th minus 10x squared plus 25. So now we just do it the way we first started to learn how to do integrals. So it's x to the 5th over 5 minus 10x cubed over 3 plus 25x plus c. All right. Now, I will tell you, I will not give you one like this and make this like a 4th power or a 5th power. That doesn't work. If something doesn't work, it's only going to be like a squared. I'm not going to make you cube something out. All right. So the reason you couldn't do the substitution, because the derivative of x squared was 2x. There was no x. I can't add variables. I can only add constants. All right. 13. All right. 13 looks very similar to 4. It's just kind of reversed. All right. So we have 2 trig functions, secant and tangent, different powers. So we pick the one with the highest exponent. So in this case, it's going to be secant 2x. All right. Then we take the derivative of secant. If you forget, you can always look at your integrals, but hopefully I remember secant is secant tangent. It says it right there. All right. So it's secant 2x tangent 2x times the derivative, whatever comes after it, which was 2. 2dx. Okay. Now, all of this needs to be here. So there's tangent 2x. I needed 2 in there, so I'm going to have a 1/2 on the outside. But I need secant. Well, I do have secant. Secant 2x here. How many do I have? I have 4 of them, which means I only need 1. So this is now going to be a 3. All right. So this is gone along with one of the secant 2x's. That's going to be my du. All right. So now instead of having 4 secant 2x's, I only have 3. So one of the examples we did in our notes today. So this is, whoops. But secant 2x is our u. So it's just u to the third. So it's 1/2 integral of u cubed du. So it's 1/2 u to the 4th over 4 plus c. So my answer is secant to the 4th 2x over 8 plus c. Remember, I don't care if you put the 4, you write it this way, where the exponent is in between there, all right? Or if you write it this way, where you put it as the quantity raised to a power. Doesn't make a difference. Both are correct, okay? All right. So when we have a trig function on the bottom, hopefully you guys remember that one thing you can do is that what is the reciprocal of cosine? The reciprocal of cosine is, what is it? Cosine goes with secant. So it's 2 secant squared 3x dx. That's what I can write this as now. All right. Now, I have one trig function. Whenever you have just one trig function, it's whatever comes immediately after the trig function. Okay, so it's going to be 3x in this case. All right, so du is going to be 3dx. Okay, now I have a dx. I don't have a 3, but I have a 2. Well, this 2, I can just move to the outside and get out of there. But I have to add in a 3. But that means I then need to put a third on the outside. And if I move that 2, what's a third times 2? Well, 1/3 times 2 is 2/3. So 2/3 integral, all right, of that's outside. This is my du. I'm left with secant squared 3x, which is secant squared u du. Hopefully everyone should know what the integral of secant squared u is du. And if you forget, you look over here. Where's integral secant squared u, secant squared u, secant squared u? Oh, there it is. All right, secant squared u du is tangent u plus c. So it's 2/3 tangent u plus c. So 2/3 tangent of 3x plus c. Now, this is the same thing as writing 2 tangent 3x, all of that over 3 plus c. But once again, this doesn't make a difference. It's the same thing. All right. All right, last one. We have a quantity being raised to, because we're not doing this one. All right. We have a quantity being raised to a power, even though it's on the bottom. That's okay. So we're going to make u the 7x minus 2. All right. The derivative of that is 7dx. All right, well, there's my dx. What am I missing? I'm missing a 7. Once again, this 3 means nothing. Move it to the outside. So there's going to be 3 on the outside of the integral, but there's also going to be, I need a 7, because that's my du. So I put a 1/7 on the outside. 1/7 times 3 is going to give me a 3/7. All right, so then I have du over u to the 4th. Well, that's 3/7 integral of u to the -4th du, which is 3/7 times u to the -3rd over -3. These 3's cancel, plus c. So I am left with a negative 1 over 7. Remember, this has to move to the bottom. So it's 7x minus 2 to the third power plus c. The 3's canceled. And the negative 1 comes because we had a negative here. There's our answer. Right? Didn't have to do 16. And that's it. All right. We will be spending quite a bit of time practicing these. All right. I'm going to have a Zoom session later this week. If you have any extra help review questions they want to go over. All right. Hope you guys have a great day.